and welcome to the BCA Industry Sharing Session on Enhancements to Buildability Framework. My name is Siti from BCA, your MC for this afternoon's session. To accelerate the adoption of design for manufacturing and assembly, the enhanced Code of Practice on Buildability and changes to the Building Control, Buildability and Productivity Regulations 2011 will take effect on 30th April 2022. This complimentary industry sharing session will provide a platform for industry stakeholders to be updated on the key enhancements to the Buildability framework. Before we start, I would like to quickly run through some housekeeping matters. Please note that as participants, you are on mute setting. Should you have any questions, you may do so by clicking the Q&A button on your screen to type in your queries or inputs. Do also note that when the session ends, you will be directed to access an e-evaluation form after you have exited the webinar. Once submitted, you will be able to download the speaker's presentation materials via the website as shown. Allow me to share the overview of this afternoon's program. The sharing will start with introduction by BCA and followed by BCA presentation. The session will then end off with a Q&A session. Let us first invite Mrs. Fu Liu Che Hong, Director, Buildable Design Department, Construction Productivity and Quality Group, BCA, to give the introduction. Che Hong, please.
Hi, good afternoon, everyone. Thank you for attending this webinar. I will give a short introduction before I pass over to Jiamin, who will share more details of the upcoming changes to the Buildability framework. As you are aware, the buildability legislation encourages designers to work together to deliver buildable designs to facilitate more productive construction downstream. We have raised the minimum B scores of building projects and enhanced the buildability framework progressively over the years to raise the standards for manpower efficient designs and technologies. In recent years, BCA has partnered the industry to champion the adoption of DFMA to change the way we build. DFMA is a key thrust of the construction industry transformation map. The use of DFMA is more productive and allows firms to become more manpower lean. Driving the adoption of DFMA will reduce our reliance on workers. On this, the industry has progressively built up capacity and capability in DFMA. This was driven mainly through public sector taking the lead and through tender conditions for sales for sites under the government land sales program. With lead demand having been introduced, we need to update the buildability framework to level up DFMA adoption industry-wide. We aim to make DFMA the mainstream way of construction, especially for large projects. Large projects have greater scope for DFMA adoption and have more significant impact on manpower savings and productivity improvement. We have started with large residential projects in 2020, and from the end of this month, we will raise the minimum B scores for the remaining large developments. In other words, all large buildings must be designed in ways that require less manpower to construct. We have made this move together with other changes to the buildability framework in close consultation with industry stakeholders. We need to work together to enhance productivity and accelerate our transition towards manpower lean construction. Every stakeholder, from designers, developers, builders to prefabricators, play an important role to advance DFMA. And I believe that together, we can deliver well-designed buildings with the use of DFMA technologies. And on this note, I shall now hand over to the MC Siti. Thank you.
Thank you, Che Hong. Let us now invite Ms. Wong Jiamin, Senior Manager, Buildable Design Department, Construction Productivity and Quality Group from BCA to share on the enhancement to Buildability framework. Jiamin, please.
Thanks, Che Hong and Siti. Good afternoon, everyone. I'm Jiamin. In my presentation, I'll be covering the following: the phase enhancements to Buildability framework to drive DFMA adoption, the new buildability requirements, which would take effect from 30 April 2022, as well as the requirements for collection of off-site construction productivity data. Should you have further queries along the way, you may use the Q&A function in the Zoom platform to raise your queries. My colleagues would be glad to assist you, but do give us some time to reply. Towards the end of my presentation, I would also be going through some of the frequently asked questions and also host a Q&A session with Chee Hong. As we know, the COVID experience has revealed our vulnerabilities on manpower and supply disruptions. Currently, we are heavily relying on large numbers of workers to support the construction industry. With the limited source of labor supply, it is also increasingly difficult to hire workers. And most of them live in dense dormitory conditions, and that becomes a key vulnerability for the next pandemic. To adapt to a post-COVID future, we have to transform the way we design and construct buildings and work towards achieving a leaner workforce. Design for manufacturing and assembly, or in short, DFMA, is one of the key transformational technologies to help raise the construction productivity. And with DFMA, we can build more efficiently to prefabricate building components in a controlled factory for on-site assembly. This way, we can achieve time savings with concurrent works being done on-site and off-site. It also creates better jobs in the built environment sector, a more conducive and safe working environment, reducing the disamenities to the public, as well as achieving better construction quality. To kickstart our DFMA transformation, we have conducted extensive consultations with industry stakeholders, including developers, consultants, builders, and prefabricators, as well as various trade associations and chambers. We have gathered valuable inputs from our engagements and established a stepwise approach to raise productivity standards for large projects with gross floor area equal and above 25,000 square meters. These projects utilize more manpower and have the economies of scale to adopt DFMA. As part of our phase 1 enhancements, we started raising the requirements for large residential non-landed projects. In 2019, these projects account for the largest share of industry GFA, about 50 to 60%. And they are also the group that comes with the most labor-intensive activities. While raising the minimum B scores, we introduced outcome-based options as an alternative to meet higher standards. These options include adopting stipulated prefabrication or DFMA levels. Projects adopting for outcome-based options are not required to compute B score and C score, so it provides more flexibility to the industry. In 2020, we revamped the Buildable Design Appraisal System, also known as BDAS, to integrate DFMA into each discipline of work as part of our phase 2 enhancements. To cater time for industry to adjust to challenges brought about by COVID and be familiar with the new framework, the minimum B scores were calibrated to 2019 standards. At the same time, we extended outcome-based option, the open option, to all large projects. So projects adopting open option would need to demonstrate a stipulated minimum level of productivity improvement. So now we are coming to phase 3 to drive the remaining projects, the large non-residential projects, including commercial, industrial, institutional, and others, to adopt DFMA. We will be raising the minimum B scores and establish outcome-based options for these projects. To enhance supply resilience, we have to instill DFMA design principles to promote more buildable designs for the ease of manufacturing and assembly. We aim to drive greater modularization by requiring the adoption of industry standard components. These changes in phase 3 would apply to new projects submitting planning permission application to URA on or after 30 April 2022. Let me take this opportunity to recap on the changes to the Buildable Design Appraisal System, the BDAS, in greater detail. Over here, you will be able to see the differences between the previous and the current version. We have restructured BDAS to make DFMA an integral part of our framework, so as to encourage adoption of prefabrication and modularization within each discipline of work, namely structural, architectural, and mechanical, electrical, and plumbing. There's also a new section on innovations to encourage new productive designs, materials, technologies, and practices. Last but not least, we also have different point weightages for different development types. This provides greater granularity and encourage more buildable designs in the particular discipline of work that requires more manpower. I will be sharing more details in the subsequent slides. The revamped BDAS allows designers to select appropriate DFMA systems to meet the minimum buildable design score. We have a wide range of technologies under each discipline of work, the structural, architectural, as well as the MEP. I'll be showing some examples in the next slide, but over here, the different technologies are allocated with these score points according to the manpower savings achievable in lieu of the labor saving index. Points are also given to award the extent of modularization, such as repeated designs, use of standard components like columns, beams, prefabricated bathroom units, MEP pump skits. And for the innovation section, it awards bonus points for the use of new technologies, which can achieve at least 20% manpower savings. Some examples include prefabricated common toilets or prefabricated kitchen units. We have identified a wide spectrum of productive technologies covering all three disciplines of work. For structural system, you may consider adopting advanced precast concrete systems, which is generally suitable for all development types, structural systems for commercial projects, mass engineered timber for institutional projects, prefabricated pre-finished volumetric construction for residential and hospitality projects. These DFMA tech are able to achieve significant manpower savings of about 20% to 40% at project level. And beyond this, there are also productive dry architectural technologies such as engineered timber floor, prefabricated and pre-finished walls, prefabricated bathroom units, kitchen units, and common toilets. For prefab MEP, there are also components such as flexible water pipes, sprinkler droppers, or assemblies such as prefabricated horizontal, vertical, or plant modules. Some of the MEP modules can also be integrated with structural or architectural elements. Based on our productivity data collected from actual projects through the Electronic Productivity Submission System, also named as EPSS, we understand that the manpower utilization is different for each development type across different disciplines of work. So as you can see here, the point weightages for Buildability 2019 is as follows. We have 45 points for structural, 45 for architectural, as well as 20 points for DFMA. So from the EPSS data, we understand that for private residential non-landed projects, 35% of the manpower is spent on structural, 45% on architectural, and 20% for MEP works. However, the distribution can be different for public projects, in particular the residential non-landed projects by HDB, as the extent of architectural works in terms of finishings and also the MEP works are also lesser compared to the private non-residential, residential non-landed projects. Hence, we revamped the appraisal system with different point weightages for each development type. Over here, we have grouped them into various categories, and each of them adds up to 100 points. This would foster greater collaboration amongst designers to plan for more buildable designs in that particular discipline of work that requires more manpower. With the change in point weightages, we had to rebase the minimum B scores. Let's take a look at the minimum B scores for Buildability 2019, 2020, as well as 2022. For mid-sized projects with GFA between 5,000 and 25,000 square meters, the minimum B scores are as follows. It may seem odd to you that the minimum B score for 2020 and 2022 is now lower than before. For example, for residential projects, currently it is 68 points compared to 85 points in 2019. It is due to the calibration on minimum B scores with the revamped appraisal system. It is not a decline in productivity standards. For large projects with GFA equal or above 25,000, we started raising the minimum B scores for large residential non-landed projects in 2019 from 90 points to 92 points as part of our Phase 1 buildability enhancements to drive DFME adoption. For Phase 2 enhancements in 2020, we revamped the appraisal system and rebased the minimum B scores to 2019 standards. Take the residential projects as an example. We have 92 points in 2019 versus 80 points in 2020. They are actually comparable. For Phase 3 enhancements, we will be raising the minimum B scores for non-residential projects to adopt DFMA. And this will apply to new projects applying for planning permission on or after 30th April 2022. In the subsequent slides, I will be covering the new requirements in detail. Since 2019, designers actually have the flexibility to select one of the three ways to meet buildability requirements. First, it would be the code compliance option by meeting the minimum B score. Second, we have the deemed acceptable solutions with stipulated prefabrication levels, system format requirements, or DFMA coverage. These were introduced currently for the large residential non-landed projects at the moment. Third, we have the open option, which seeks to encourage projects to adopt novel, innovative, and productive technologies outside of the current DFMA continuum. We require projects to demonstrate through a proposal minimum of 20% productivity improvement over 2010 levels. The productivity data are published in our website. For large government land sales projects stipulated with DFMA or minimum productivity improvement requirement, you may consider opting for one of these options if eligible. Last month, we have issued a circular to inform the upcoming changes to buildability requirements. So in the next slide, I will be sharing more details on our proposal, as well as the submission requirements. Okay, let's first zoom in into the large residential non-landed projects. Here are the requirements for Buildability 2020. Both public and private residential projects are required to meet a minimum B score of 80 points. Alternatively, they can also opt to comply with any of the outcome-based options here, whichever suitable. In 2022, we maintain the minimum B scores of 80 points, but streamline the outcome-based options as follows. The differences are highlighted in bold. So for option 1, it is actually a combination of the option, the previous option 1 and 2 in Buildability 2020. We noted that the industry has demonstrated capability in adopting larger extent of prefab walls. Hence, we are raising the prefab architectural level to 80%. For option 2, we will include the requirement for 70% system formwork for the remaining cast in situ areas. And for the third option, we will raise the requirements from 20% to 25% productivity improvement over 2010 levels. For non-residential projects, here are the current minimum B scores and outcome-based options. So come 2022, 30th April, we will be raising the minimum B scores at the same time introduce outcome-based options for these large projects for industrial, commercial, as well as institutional and other projects. For large industrial and commercial projects, the new minimum B score would be 70 points with the aim to drive DFMA adoption and also to provide greater modularization and standardization. As for the institutional and others category, it actually covers more diverse range of projects, including nursing homes, schools, community facilities, and more. Some may have lesser scope for modularization and standardization, and hence we are setting a lower minimum B score at 66 points. So to cater more design flexibility and encourage innovation, we are introducing these three outcome-based options as follows. So option 1, we would require projects to fulfill a minimum of 60% prefab or 50% DFMA coverage for steel, APCS, or MET. For architectural levels, a minimum of 80% prefab or 70% for office projects. Office buildings tend to have lesser internal walls since office space is usually tenanted out. So that explains why the percentage, the coverage is slightly lower. So for MEP, similarly, we require a 50% prefabrication level. System formwork, 70% for the remaining CAS-62 area. For option 2, we have 60% PPVC, 50% prefab MEP, as well as 70% system formwork. We recognize that this may not be suitable for all the building typology over here, but they are still applicable to some projects such as hotels and nursing homes. So for option 3, similarly, we will increase the minimum percentage from 20% to 25% productivity improvement over 2010 levels. Building projects with GFA equal and above 5,000 square meters are required to make buildability submissions when making structural and building plan submissions. Let me guide you through the submission requirements for the three different options. So this option is the code compliance options, which most of you are familiar with. We require projects to submit B-score form with computation at STBP submissions, as well as BSO3 for as-built TOP submissions. Both submissions would require you to prepare a buildability detailed design implementation, also named as BDIP. And within the BDIP, you should be including the markups on plans with computation of coverage of building systems and components. You are also required to submit site photos at TOP stage. We also require the builders to prepare constructability score form, which is the CSO1, and the constructability implementation plan. Next, the outcome-based option, deem acceptable solutions. For B-score, for this option, similarly, we still require you to submit the B-score form for declaration of the options chosen. Yeah, so within the form, you need to indicate which deem acceptable solutions you're opting for both BSO1 and as well as BSO3. However, you need not compute the B-score for the individual blocks. You will only be required to submit the inputs on the summary page. Similarly, we will also require you to submit a deemed acceptable proposal to illustrate the extent of use of the DFMA systems, prefabrication, as well as system formwork. And Also to supplement us with the site photos at TOP stage. Coming to the open option, which is catered more for projects with novel, innovative, and productive construction methodologies. We do require you to submit the score form to declare your choice of option, which is the open option, for BP submission as well as built TOP submissions. So within on top of the BScore form, you are required to submit the project productivity improvement plan, PPIP, to explain the design concepts, including the proposed design technologies and systems, the level of use of prefabrications, buildable features such as modularization, standardization efforts, use of offsite finishes. You may also adopt innovative features and robotics and automation for your project. Within the PPIP, you are supposed to list down the proposed construction process as well as the construction management. With this, you would be required to demonstrate that the project can achieve minimum productivity improvement of at least 25%. At the TOP stage, we do require you to submit the proposal with the site photos. So rest assured, the presentation slides will be shared with you towards the end of the webinar. So for projects adopting open option, you are advised to seek in principle acceptance for the concept proposals through Building Innovation Panel, BIP, in advance before making building plan submissions. PIP aims to assist firms in expediting evaluations and obtaining regulatory clearance for the use of innovative methods, processes, technologies, as well as materials. So we do suggest you to write into us for pre-consultations early. Okay, now how do we compute the prefabrication level for different disciplines of work? We note that the prefabrication is actually challenging for basement works, and hence prefabrication level is measured based on the superstructural works. So for prefab structural systems, it is measured based on the total constructed floor area, also known as CFA. And these are the systems that are considered prefab. For example, DFMA technology such as PPVC, APCS. APCS refers to advanced precast concrete systems, the use of structural steel as well as mass engineered timber, or hybrid of these systems can be considered. Yeah. So the use of prefab slab with a combination of other prefab elements are also considered. For prefab architectural systems, it is measured based on the total wall length of the superstructural works. These systems can include the use of PPVC, PBU, prefab bathroom units, prefabricated and pre-finished walls. Some may come with MEP services, or form precast walls, dry walls, curtain walls, prefab precast walls, as well as lightweight concrete panels. For prefabricated MEP systems, for a start, we actually identify a set of qualifying criteria which are suitable for implementation of prefab MEP systems. Hence, the prefab level is actually measured based on the qualifying area. Yeah. So in the next slide, I will go through how you actually need to compute. Okay. So prefab MEP level is computed based on the total area of prefab MEP systems, including horizontal, vertical, and plant modules, over the total qualifying area of the three systems. So for horizontal modules, the qualifying area is actually computed based on the common areas common corridor areas, including lift lobbies. For vertical modules, the qualifying area is computed based on the area of the risers or service ducts. This can include chilled water, plumbing and sanitary, firefighting services, as well as electrical risers. For plant modules, the qualifying area is based on the area of plant room or plant skid serving the various pump sets listed here. It can include potable water, new water, sprinkler, hose rail, chilled water, as well as condenser water. The details of the qualifying area can be found in the BCA form. There are also some exclusions that we acknowledge that it is not commonly adopted. So more details can be found in the BCA form. Okay, if you want to find out more about prefab MEP systems, just 2 months ago, we have organized a BCA STARS industry sharing on prefab MEP systems. The topics include key principles and strategies in developing an ecosystem in Singapore, IDD, sharing by industry players, as well as accreditation schemes. For comprehensive details on how to measure the prefab MEP coverage, you may scan this QR code to download the materials. There's also a webinar recording for you to download. Besides this, we also have an upcoming introductory course on modular prefab MEP design and prefabrication. This is a course jointly organized by BCA and STARS. You may scan the QR code here to register for the course. I will pause here for a while for you to scan the codes. Okay, coming back to the computation of DFMA coverage, prefab pre-finished volumetric construction, which is PPVC, the coverage is actually measured based on the constructed floor area of the system over the total CFA of the superstructure works or components used for resi or accommodation purposes, which includes lift lobbies as well as corridor. However, we acknowledge that there are certain areas that are not suitable for PPVC adoption. Hence, we have excluded, in your computation, you can exclude the area of E-deck, void deck, swimming pools, roofs, car parks, landscape areas. But if, let's say, the residential floor areas are at the same stories, you will need to include the areas of the PPVC modules. Hotel lobbies are also excluded in the equation. Coming to advanced precast concrete system, APCS, the coverage is actually measured based on the constructed floor area of precast slab with that comprises at least 4 out of 6 of the APCS features. These features must come with a minimum of 65% coverage. So here are the 6 features. So first of all, we have the integrated precast components comprising at least 2 structural or architectural elements. These can include double bay facade wall, beam facade wall, double tier column, precast household shelter, precast refuse chute, PBU, pre-finished facade walls, as well as precast external wall with cast-in windows. So you need to adopt one of the many examples over here for feature 1 and ensure that the minimum coverage is at least 65%. Number 2, feature 2, mechanical connection for precast column, precast wall. This includes horizontal joints such as column shoes, wire connectors, as well as grotted sleeves. Feature 3, mechanical connection for precast beams. This includes telescopic beam connectors and grotted sleeves. Feature 4, we have mechanical connection for precast walls vertical joints, which can be in form of flexible loops. Feature 5, mechanical connections for other precast components such as the use of precast staircase slide together with precast landing. Feature 6, the use of large panel slabs, hollow core slabs, and double T slabs with 2.4 meters width and above. So in order to consider the project as fulfilling the APCS, you would need to first adopt precast slab, and together with at least 4 out of 6 of these APCS features, and each must come with a minimum of 65% coverage. For more information, you can actually refer to our APCS guidebook published on the BCA website. So for the computation of coverage for structural steel, mass engineered timber, or a hybrid of DFMA technologies, it is similarly based on the constructed floor area of superstructure works using any of the materials, structural steel, MET over here. Yeah. So for hybrid structures, all 3 structural elements, the beam, the columns, and the slab, have to be either precast concrete, steel decking, or MET slab. Okay, coming to the measurement of system formwork, it is actually measured based on the superstructure works, and both horizontal and vertical system formwork must meet a minimum of 70% based on the remaining cast in situ area. For illustration purpose, let's say a project is opting for to comply with one of the deemed acceptable solutions of maybe 60% prefab structural system and 80% prefab architectural system. So this project would need to adopt 28% horizontal system formwork for slab and beam out of the total constructed floor area. How do I get this 28? It's basically 70% of the remaining 40% cast in situ works. For vertical system formwork requirement, project will need to adopt 14% based on the vertical contact area, which is 70% of the remaining 20% cast in situ wall systems. So for projects adopting prefabrication beyond the stipulated requirement, these areas can also be counted as part of fulfilling part of the system formwork requirements. In addition to raising the minimum B score and introducing the outcome-based options, we are making some enhancements to the framework to encourage greater design modularization. Modularization optimizes the benefits of DFMA and paves the way for more cost-effective prefabrication of components. Our key strategies include, first, by expanding the scope of mandatory items. So over here, our enhancements are actually highlighted in blue. First of all, we increase the coverage for these 2 items over here, the use of prefabricated staircase, as well as precast refuse chute. Currently, we require a minimum of 65% precast staircase and precast refuse chute to come in industry standard dimensions. We will increase the coverage to 80% for these 2 items. Next, we move some of the non-mandatory items into the mandatory list. So over here, you can see that we have PBU, new item, PBU, as well as precast household shelter, both in industry standard sizes. Actually, we find the scope for PBU and precast household design to be standardized without causing much impact on the overall design of the project. So for a start, we require adoption of minimum 65% PBU and 65% precast household shelter, of which 60% have to be in industry standard sizes to allow some design flexibility. On top of this, we are also shifting some of the scoring items from the project level up to the industry level, especially for components for residential non-landed projects, as the user requirements are more consistent. This includes industry standard dimensions for PPVC modules for bedrooms in terms of the width, as well as windows and the use of precast beam in industry standard dimensions. Last but not least, we are adding new items for scoring at project level, which includes these two items here, precast facade walls in multiples of 300 mm, as well as precast service ducts in multiples of 150 mm. These are non-mandatory items and will be given B score points upon adoption. So from our consultation with the industry, we have assessed the readiness to adopt more buildable designs and have refreshed the list of standard components to ensure relevance while providing design flexibility. Going forward, BCA is working with specifiers and precasters to jointly develop a catalogue of standard precast components. So for more details on the standard sizes, we will publish the new B-score form for Buildability 2022 on our BCA website. Okay, in Buildability 2022, we are also introducing a new requirement for PEM&E to jointly endorse buildability submissions with QP for architectural and structural works. Since 2017, we have introduced DFMA as part of our framework, and prefab MEP items have been in the framework for over the past 5 years, as they also contribute towards raising construction productivity. So for projects subject to Buildability 2022, we would require PEs for M&E works, executing detailed design to prepare B-score for the MEP section of the form, as well as the Buildability Detailed Design Implementation Plan, also known as BDIP, with drawings with markups on plans and computation of coverage for MEP modules and systems. With this, we seek to foster greater collaborations across all disciplines during the upstream design stage, and to consider user, spatial, and loading requirements to accommodate prefab MEP systems upfront. Okay, coming to one of the last requirements. Currently, we do require builders of all building projects with GFA equal and above 5,000 square meters to submit construction productivity data monthly through the Electronic Productivity Submission System, also named as EPSS. With DFMA becoming the mainstream way of construction, more on-site works will be shifted off-site. And to effectively measure productivity, BCA requires builders to submit both on-site and off-site productivity data. Hence, for projects issued with permit to carry out structural works on or after 30th April 2022, we would require both on-site and off-site manpower data to be submitted through EPSS. So in terms of the submission workflow, the DFMA facilities, including prefabricators, precasters, PPVC, PBU fit-out suppliers, structural steel suppliers, specialists, MEP subcontractors, including those overseas, would have to provide offsite manpower data to the builder. The appointed builder would then collate both on-site as well as off-site data for submission to EPSS on a monthly basis. BCA would be providing a template on our EPSS portal from 30th April 2022, and builders will need to log into your account to download the template. If you do have further inquiries, you may drop us an email at bca_epss@bca.gov.sg. Okay, now I will be going through some of the frequently asked questions. Some of you may ask, why is the new minimum B score lower than before? Actually, the new minimum B score is not a decline in standards. It is due to the revamped buildable design appraisal system in 2020, whereby we restructure the appraisal system and give different point weightages for the various discipline of work, and depending on the development type that you are subject to. Each technology is allocated with points based on manpower savings, and we have removed the use of labor saving index. Yeah, so in order to compute the correct minimum, correct B score for your project, please ensure to use the correct B score form to assess the adequacy of your design. Question 2, for outcome-based options, can I opt for deemed acceptable solutions for smaller projects with GFA less than 25,000 square meters? Unfortunately, outcome-based options are currently available for large projects with GFA greater or equal to 25,000 square meters only. Next, for outcome-based options, would you be able to adopt deemed acceptable solutions for mixed developments? Yes, mixed developments can choose to comply using the deemed acceptable solutions. However, each of the building use must meet the required minimum prefabrication levels or DFMA levels. So let's say if you have a residential non-landed project with commercial use, the residential non-landed project would have to, component would have to meet the requirements. And at the same time, for the commercial part, you would actually need to also meet the structural, architectural, MEP, and system format requirements. So for mixed developments whereby a particular extent of use is small, we would suggest you to consult us separately. Okay, coming to again on outcome-based options, what if you adopt prefab systems beyond the requirement? And how are we gonna compute the system format requirement? So first of all, for projects adopting outcome-based options, we would require 70% of the remaining cast in situ area to adopt system formwork. So if you have adopted prefabricated systems beyond the stipulated requirements, these can be considered towards fulfilling the system formwork requirement. And for computation of horizontal system formwork requirement, the constructed floor area of DFMA systems, including the use of PPVC, precast RC slabs, steel deckings, or other prefab structural systems can be considered. So let's say if you have a residential non-landed project which chooses to comply with the 60% PPVC as well as the 70% system formwork option, here's an illustration. assuming we have a project with total CFA of 100,000 square meters, and out of which 60% have to be of PPVC. So for the purpose of illustration, we assume that 60% PPVC coverage equates to 65,000 square meters in terms of CFA. So on top of that, let's say the project has also adopted some form of precast slab. It could be 4,500 square meters. We actually would take 70% of the remaining cast in situ area, which is 24,500 square meters, and subtract the additional CFA of this precast slab, 4,500 square meters. So this gives rise to the horizontal system formwork requirement of 20,000 square meters for the cast in situ superstructure works. Similarly, for computation of vertical system formwork requirement, the wall length of the FMA systems, including the use of PPVC, precast walls, and other prefab systems can be considered. So using the same example, let's say a project has a total wall length of 10,000 meters, and assuming that 60% PPVC requirement, the coverage equates to around 7,000 in terms of square meters, in terms of wall length. And on top of that, the project has adopted prefab walls of 1,000 meters with vertical contact area of around 10,000 square meters. So we would be taking the 70% of the remaining vertical contact area, which is 12,000 square meters. 12,000 is actually converted from 2,100 meters in terms of wall length. This refers to the cast in situ wall length. So we take 12,000 and subtract by the 10,000 square meters in terms of vertical contact area. And this would give you 2,000 square meters. And for your project, you will need to adopt horizontal system formwork requirement for these 2,000 square meters for cast in situ superstructure works. So over here, I would like to conclude my presentation, and we'll be handing over to Siti.
Thank you, Jiamin. We will now move on to the Q&A session. We have Mrs. Fu Liu Jae Hong, Director of BCA, and Jiamin to join us on the panel. You may participate in the conversation by posting your questions or queries via the Q&A button on your screen. Over to you, Jae Hong, please.
Yeah, thank you everyone for listening in to Jiamin's explanation and clarification on what the upcoming changes to the buildability framework will entail. It can be quite a mouthful to digest during this webinar. So if you do have any questions right after you have seen the slides in detail, we always welcome your queries because this will also help us to review certain areas that we might not have foreseen, or there may be certain projects that are unique in nature and the enhancements may not be able to cater for every specific project. Okay, I'm trying to see some of the common questions that have been raised.
Okay, maybe I will take one of the questions from River Law. Okay, for mixed developments projects of more than 25,000 square meters, if individual building use component, for example, commercial, is less than 25,000 in terms of GFA, would it still need to comply using outcome-based deemed acceptable solution, or only individual users which are more than 25,000 square meters need to comply? Okay, on to his query, you can actually choose one of the three ways to meet buildability requirements. The first would be the computation of buildable design score, and second would be the outcome-based deemed acceptable solutions or open option. Third, yeah. So for the use of if let's say you were to adopt deemed acceptable solutions, noted that one of the building use is less than 25,000 in terms of square meters. So that particular part of the development would still need to fulfill the minimum prefabrication level or DFMA coverage. So both users would need to both of the building use would you need to ensure that both building users comply with the specified stipulated minimum prefabrication level or DFMA coverage.
Yeah, maybe I add on to what Jiaming has clarified. For mixed development, sometimes it really depends on the quantum of each use. So we actually need to see every project on its own. If a particular usage is quite insignificant, all of the total GFA of that development, I think we can look at it from the predominant usage of the mixed development alone. So it's really a case by case. So if there are any queries or you have any projects at hand that you need to seek clarification, I think we are prepared to actually take a look together with you. I think there are also quite a number of queries about certain projects. They may not be repetitive in nature, and for such projects, the extent of standardization may be affected. So for such projects, again, we have been receiving specific queries from consultants like yourself. So we do have to review each project on a case-by-case basis, because we do recognize that every project sometimes is due to functional requirements whereby you cannot have typical floor height, for example. So for such projects, we can review them favorably if the case is as such. For those who have asked about the details, right, we will be updating the core practice, and this will be put on our website soon. We are trying to cover as much as possible within this version of the core practice. Some of you asked, how do you contact us for specific questions other than emails? Okay, in the circular, I do have my two colleagues' telephone numbers, so you can actually call them. Otherwise, you can also drop me an email, and then if there's a need to make a phone call, to clarify things, I'm prepared to take the phone call.
Okay, I received a question from Lim Yi Ho on the computation of vertical system formwork requirement. For computation of system formwork, in particular the vertical aspects, we are actually computing based on the vertical contact area of the wall systems. So you would actually need to convert 2,000 and 100 meters in terms of wall length to the vertical contact area. I would also take another question from Cruz. For retention works, office buildings with areas more than 2,000 square meters, will there be a need for constructability C-score submissions? C-score submission will be required for projects with GFA more equal or more than 5,000 square meters. If let's say that it is a an ANA project, you would still need to submit C-score if let's say the GFA exceeds 5,000 square meters. Another question on from Lua Kok Leong. The first URA planning permission was submitted in February 2019 with GFA of less than 5,000. Can the B-score be exempted? Okay, Buildability 2019 would only apply to projects which submitted planning permission application on or after 15 December 2019. So B-score is still required for your project.
Yeah, I take on the question from Ronaldo, asking about the computation for PPVC coverage. Okay, the precast household shelter as well as the staircases will be included into the total CFA. That means that they contribute towards the denominator of the calculation.
For ANA works, do we need to adopt the new scores too? Do we just count the ANA part? Yes, we do have a minimum B score for ANA works. It is 42 points for Buildability 2020 as well as 2022. The minimum B scores will be available in the B score form.
There is another related question on PVVC coverage as to whether the sky terrace areas as well as the landscape area can be excluded. This can be excluded from the denominator, yes. There is a question from John. Yeah, we do have the previous guidebook on buildable design appraisal system. I think with the recent changes, I think we are working on updating this guidebook so that everybody has a common understanding and it gives a better understanding on how the various items are being computed and scored.
Okay, I'll be taking a question from Annie Lim. How do we split basement block for mixed-use development? So within the B-score form, we actually segregate out the superstructure score for B-score computation for superstructure works and basement block. So if you do have commercial use which are situated in the basement, they can be scored in the basement block.
Yeah, so through Yokeling, yeah, some of these questions we have attempted to answer live. So we will still give a written replies to all the questions that we have answered live, so that everybody, we have a set of the queries and our answers. Okay, I'll take the question from Eileen. Yeah, which Jenny, I think, is trying to reply. Okay. We do still have that list of exempted projects in the core practice. Yeah. So by and large, the type of developments that are exempted are still the same because these are actually stated in the buildability regulations.
To any LIMS question, what if the basement is shared between residential and commercial, for example? Okay, for all basement works, we do have a dedicated tab within the B-score form for you to compute the B-score. So for this, you can actually score based on the residential use or the commercial use based on the GFA apportionment. Okay, another question from Norwin. What are the industry standard size or dimension for PBU and precast household shelter? We will actually publish these standard dimensions in our B-score form for Buildability 2022. The form is still work in progress. We will be uploading the form by the end of this month. For reference, you can actually refer to the Buildability 2020 B-score form for more information.
Okay, I'll take on the question from Winston. Okay, how is BCA able to quantify the 25% productivity improvement? Okay, this is a good question because the open option is actually meant to allow designers and the builders to come together and propose systems that are not actually found in our core practice. So these are generally what we would say innovative proposals that probably have not been adopted in our local projects. So for such projects, one way is if it's an innovative system, you can actually come to the BCA, the Building Innovation Panel, for us to assess this innovative proposal together with the rest of the technical agencies. Otherwise, another way that you can actually demonstrate how your system or proposal can achieve 25% is to use simulation. In fact, if you do have other countries, case studies from other countries, this can also be submitted to substantiate the manpower savings that can be derived from this particular innovation. So to be frank, till now, we have not have any project that has come in for this open option. Generally, project coming as through the deemed acceptable solutions, which are either for residential project PVC or the high prefabrication level. So far, we do not have any project that come in for this open option yet. There is a question from Kim Cheong about what is the best buildable score for a RESI project. I mean, now that the framework has been revised and revamped, it will take us some time to actually see what are the systems that are put in by residential projects for that matter. And and then probably through our so-called database, we'll be able to see what is the best project in terms of B score that have achieved as a result of these revamped BIDAs. There are quite a number of questions on the holocore step width. Okay, we have specified for the holocore width to be 2.4 meters because the features of APCS, right, is to encourage simple design, standard components, as well as single integrated components. So we have included 2.4 meter width for the holocore step. But we are prepared to review these criteria if that is I mean, if there are concerns about this size, and actually your project with a 1.2 meter width, that is sufficient. Let us take this back because I see there are quite a number of questions on this.
Okay, we received a question from Mr. To Futai. Do you allow builder to claim innovative points under constructability framework if it is scored under buildability? For example, the use of 80% architectural is designed to be prefabricated. Actually, if you were to opt for outcome-based options, deemed acceptable solutions, which includes a minimum of 80% prefab architectural system, there is actually a default C-score being assigned to your project. This default C-score is actually, we actually worked out the C-score internally, and we will publish the minimum, the default B and C score in our code of practice.
There is a question about whether BCA will share with the industry the new form. I guess you can actually, we do have training courses, but other than that, I think you can drop us an email and we can have a session to go through the form if needed. Because otherwise, I also agree that now that the BIDAS has been revamped, this is quite a big change from the previous framework that everyone is very familiar with. So maybe you drop us an email and we can follow up separately.
Okay, I would like to answer a question from Sony. Can you explain a bit more on the 70% system formwork requirement? What are the acceptable solutions? And how would the computation be submitted? Is it part of the new form? Okay, for projects opting to comply with deemed acceptable solutions, which include the requirement of 70% system formwork, the builder would actually need to submit some plans akin to the constructability implementation plan. This plan would require you to show the extent of use of system formwork, as well as to compute, to mark up the area of these the location of the formwork used, as well as to show the computation in terms of the project level adoption. So As for submission requirements, you can submit together with the other documents during BP submission stage as well as TOPS build submission stage. Another query from Mr. Singh on EPSS. Is EPSS also needed if offsite precast is overseas? Okay. Yes, it is still required. So basically, all DFMA facilities would have to submit offsite data to the builder for builder to collate and submit to BCA monthly. So the reason why we want to collect monthly offsite data from overseas suppliers is that these data actually support BCA's review and measures in enhancing precast supply resilience. Yeah, the appointed builder would actually collate all these data from the various suppliers for this project and into the BCA template and submit through the email that I've provided earlier on. It is bca_EPSS@bca.gov.sg.
To Jenny Sui's query, the enhancements are tied to the date of the first planning application to URA. So meaning that is on the 30th of April this month, end of the month. Okay, I take on reverse query. It's asking, the question is about the outcome-based option, whether the project team need to do their own internal so-called assessment on the intended 25% productivity improvement, or should this be done in consultation with BCA? As mentioned earlier, I think this option is really new. So we would suggest that you talk to us. We look through the proposal together and then we can advise accordingly. There is another question about the hollow core slab. So as I mentioned earlier, we will review this requirement.
I will take on another question from Sony. In one of our slides, we do require, we have a deemed acceptable solution, which requires the adoption of 60% PPVC, 50% prefab MEP, as well as 70% system formwork. So your question is on how to compute the prefab MEP adoption. Am I correct? So the computation for PPVC coverage is different from the computation of prefab MEP systems. So for PPVC, you actually need to consider the constructed floor area of PPVC system over the total constructed floor area for your project. This option applies to commercial, industrial, as well as institutional and others category. So for the use of MEP systems, we actually are referring to the use of horizontal, vertical, and plant modules. So the computation would be based on the total prefab MEP area of the horizontal, vertical, and plant module over the total qualifying area of these three module types. Okay, I will take on a question from Ng Wei Kiang. The use of external drywall system from overseas suppliers, does it qualify for this scheme? First of all, the use of any structural, architectural, MEP system have to be in compliance with the local regulatory codes. Yeah, and approved by the authority. So if let's say you are interested to opt for the open option, however the system is currently only adopted in overseas context, you can actually come in via the Building Innovation Panel to seek approval of the use of the new systems.
I will address Lillian's question about outcome-based option, whether BCA can come up with a guide on how to compute, and is there any standard format? Okay, we will develop a guide on a standard format so that everybody is on the same page as to what BCA requires for you to demonstrate to us. To Johnny's question on whether is there any PPVC for lift core wall, so far we have not seen any. Yep. We are now at 5:25. So if you still have some questions, quickly type in and we try to address. Otherwise, I think we will actually take on them either through email or phone call from you. If there are no more questions, then maybe I pass it back to Siti.
Okay, thank you, Chair Hong. All right, we have come to the end of today's industry sharing. After exiting this session, you will be directed to access an e-evaluation form for today's industry briefing. Once submitted, you will be able to download the speaker's presentation materials via the website as shown. On this note, we thank you for your participation and making this industry sharing a success. Signing off, this is Siti from BCA.